Hello to everyone. Myself, I am G. Syam Reddy,
Yeah,
lecturer in mathematics, PR Government Degree College, Autonomous, Kakinada. On the behalf of Commissionerate of Collegiate Education AP, I am welcoming you e-learning management system. E-learning on the topic the plane. This topic belongs to first year BA or BSc mathematics subject in second semester. In second semester, the paper title is Solid Geometry. In solid geometry, before going to learn about the topic, the plane, first we will discuss the learning outcomes of the plane. After studying this, the plane, students will be able to recognize the following properties of the plane. First one, identify points, rays and segments using words and symbols. Second one, knowing the general equation of a plane. Third one, understand the transformation of the equation to the plane into normal form. Next one, identify angles between the two planes. And next one, identify the condition of parallelism and identify the condition of perpendicularity. So the chapter title is the plane. The general definition of the plane equation: a plane is a surface such that any 2 points are taken on it. The line joining them lies wholly on the surface. So the general equation of the first degree in XYZ always represent a plane. So first we can prove this statement. Let ax plus by plus cz plus d is equal to 0 and a square plus b square plus c square not equal to 0 be the first degree equation in XYZ. Now if we have to show that equation 1 represent the equation to the plane, we prove that every point on the line joining any 2 points on equation 1 also lies on the locus of equation 1. Let px1 comma y1 comma z1 and qx2 comma y2 comma z2 be any 2 points on the locus represented by equation 1. Then ax1 plus by1 plus cz1 plus d is equal to 0 and second point qx2 comma y2 comma z2, then ax2 plus by2 plus cz2 plus d is equal to 0. So let R be capital R be any point on the line segment joining the points P and Q. Then R divides PQ in the ratio lambda is to 1. Then R is equal to lambda x2 plus 1x1 by lambda plus 1, lambda y2 plus 1y1 by lambda plus 1, lambda z2 plus 1z1 by lambda plus 1. Here lambda plus 1 not equal to 0. We have to show that R lies on the locus of equation 1 for all values of lambda. Substituting the coordinates of capital R in the LHS of equation 1, we get a into lambda x2 plus 1x1 by lambda plus 1 plus b into lambda y2 plus 1y1 by lambda plus 1 plus c into lambda z2 plus 1z1 by lambda plus 1 plus d. So LCM lambda plus 1, that is equal to a into lambda x2 plus x1 plus b into lambda y2 plus y1 plus c into lambda z2 plus z1 plus d into lambda plus 1, that is equal to common lambda into ax2 plus by2 plus cz2 plus d. Next remaining terms ax1 plus by1 plus cz1 plus d by lambda plus 1. But equation 2 and 3, ax2 plus by2 plus cz2 is equal to 0 and ax1 plus by1 plus cz1 plus d is equal to 0. So lambda into 0 plus 0 by lambda plus 1, that is equal to 0, which shows that R lies on the locus of equation 1 ax plus by plus cz plus d is equal to 0. Here R is an arbitrary point on the line joining P and Q. So we have every point on PQ lies on ax plus by plus cz plus d is equal to 0. Therefore, the equation ax plus by plus cz plus d is equal to 0 always represent a plane. Next, second one, transformation of the equation to the plane into normal form. So, general equation of the plane equation is ax plus by plus cz plus d is equal to 0, comma a square plus b square plus c square not equal to 0. Here, d greater than or equal to 0 or d less than or equal to 0. That is d negative or positive. So, ax plus by plus cz plus d is equal to 0 if and only if ax plus by plus cz is equal to d comes to minus d. So, total equation dividing square root of a square plus b square plus c square, we get ax a by square root of a square plus b square plus c square into x plus b by square root of a square plus b square plus c square into y plus c by a square plus square root of a square plus b square plus c square into z is equal to minus d by square root of a square plus b square plus c square, or d is equal to minus of ax plus by plus cz. So d by square root of a square plus b square plus c square is equal to minus ax by square root of a square plus b square plus c square plus minus b by square root of a square plus b square plus c square into y plus minus c by square root of a square plus b square plus c square into z. So both equations are is of the form Lx plus My plus Nz is equal to P. Here L is equal to plus or minus square root of a square plus b square plus c square. M is equal to plus or minus b by square root of a square plus b square plus c square. N is equal to plus or minus c by square root of a square plus b square plus c square, and p is equal to minus or plus d by square root of a square plus b square plus c square. So the normal form the given equation is plus or minus ax by square root of sigma a square, that is square root of a square plus b square plus c square, plus or minus by square root of a square plus b square plus c square, plus or minus cz by square root of a square plus b square plus c square is equal to minus or plus d by square root of a square plus b square plus c square. Here d less than or equal to 0 or d greater than or equal to 0. So this form is called a normal equation of the plane equation ax plus by plus cz plus d is equal to 0. Next, second one, if two plane equations are taken is of the form a1x plus b1y plus c1z plus d1 is equal to 0, comma a2x plus b2y plus c2z plus d2 is equal to 0, represent the same plane. Then a1 is to b1 is to c1 is to d1 is equal to a2 is to b2 is to c2 is to d2. Here we can observe a1 a2, b1 b2, c1 c2, d1 d2. So different constants are here, but these two planes represented the same plane. Then to show that a1 is to b1 is to c1 is to d1 is equal to a2 is to b2 is to c2 is to d2. So the given equations are a1x plus b1y plus c1z plus d1 is equal to 0, and a2x plus b2y plus c2z plus d2 is equal to 0. Here a1 comma b1 comma c1 and a2 comma b2 comma c2 are DRS of normals to the same planes, but the normals are either equal or parallel. So a1 is to a2 is equal to b1 is to b2 is equal to c1 is to c2 is equal to some constant lambda. Here lambda not equal to 0, or a1 comma b1 comma c1 is equal to lambda into a2 comma b2 comma c2. Next one, let x1 comma y1 comma z1 be any point on the plane represented by 1 and 2. So d1 is equal to, that is equal to here a1x plus b1y plus c1z plus d1 is equal to 0. So d1 is equal to minus of a1x plus b1y plus c1z, that is equal to minus of a1 comma b1 comma c1 into x1 comma y1 comma z1, that is equal to minus of a1 b1 c1 is equal to lambda into a2 b2 c2. So lambda into a2 comma b2 comma c2 into x1 comma y1 comma z1. That is equal to minus of lambda into a2x plus b2ya plus c2z. That is equal to minus lambda into, but a2x plus b2y plus c2z is equal to minus d2. So minus of minus plus d2. That is d1 is equal to lambda d2. Here a1 is equal to lambda a2, b1 is equal to lambda b2, c1 is equal to lambda c2, d1 is equal to lambda d2. So a1 is to b1 is to c1 is to d1 is equal to a2 is to b2 is to c2 is to d2 is equal to some lambda, or a1 is to a2 is equal to b1 is to b2 is equal to c1 is to c2 is equal to d1 is to d2. So two planes represented the same plane if a1 is to b1, a1 is to a2 is equal to b1 is to b2 is equal to c1 is to c2 is equal to d1 is to d2. Next, second one, angles between two planes. Here a1x plus b1y plus c1z plus d1 is equal to 0 and a2x plus b2y plus c2z plus d2 is equal to 0. Represented the two planes. Then angles between two planes are equal to the angles between their normals. So here two plane equations a1x plus b1y plus c1z plus d1 is equal to 0. Second plane equation a2x plus b2y plus c2z plus d2 is equal to 0. So DCS of the normal of plane equation 1 is m1 is equal to a1 by square root of a1 square plus b1 square plus c1 square into comma b1 by square root of a1 square plus b1 square plus c1 square comma c1 by square root of a2 square a1 square plus b1 square plus c1 square. Next, DCS of the plane normal to the plane equation 2 be m2 is equal to a2 by square root of a2 square plus b2 square plus c2 square comma b2 by square root of a2 square plus b2 square plus c2 square comma c2 by square root of a2 square plus b2 square plus c2 square. So let theta be the angle between the plane equations 1 and 2. Then theta is equal to one of the angles between the normals of m1 in comma m2. That is equal to cos inverse of a1 into a2 by square root of a1 square plus b1 square plus c1 square into square root of a2 square plus b2 square plus c2 square plus b1 into b2 by square root of a1 square plus b1 square plus c1 square into square root of a2 square plus b2 square plus c2 square plus c1 into c2 by square root of a1 square plus b1 square plus c1 square into square root of a2 square plus b2 square plus c2 square. That is theta is equal to cos inverse of a1 a2 plus b1 b2 plus c1 c2 by square root of a1 square plus b1 square plus c1 square into square root of a2 square plus b2 square plus c2 square. So if theta is the one of the angle, then the other angle between the planes is 180 minus theta. So if two planes are parallel means theta is equal to 0 degrees or theta is equal to 180 degrees. So cos theta is equal to manki theta is equal to 0 degrees, then cos 0 is equal to 1 or cos 180 is equal to minus 1. So plus or minus 1 is equal to a1 a2 plus b1 b2 plus c1 c2 by square root of a1 square plus b1 square plus c1 square into square root of a2 square plus b2 square plus c2 square. Then simplifying a1 a2 plus b1 b2 plus c1 c2 whole square is equal to a1 square plus b1 square plus c1 square whole into a2 square plus b2 square plus c2 square. That implies a1 square, a1 square next b2 square plus a1 square into c2 square plus b1 square into a2 square plus b1 square into c2 square plus c1 square into a2 square plus c1 square into b2 square is equal to, so the a1 square a2 square both sides cancel, b1 square b2 square both sides cancel, C1 square, C2 square, both sides cancel. Remaining 2A1, A2, B1, B2 plus 2B1, B2, C1, C2 plus 2C1, C2, A1, A2. So total A1 square into B1, A1 square, B2 square plus A1 square, C2 square plus B1 square, A2 square plus B1 square, C2 square plus C1 square, A2 square plus C1 square, B2 square minus 2A1, A2, B1, B2 minus 2B1, B2, C1, C2 plus 2 minus 2A1, A2, C1, C2 is equal to 0. That implies it total value represented as A1 B2 minus A2 B1 whole square plus B1 C2 minus B2 C1 whole square plus C1 A2 minus C2 A1 whole square is equal to 0. Here x square plus y square plus z square is equal to 0 if possible. Either x is equal to 0 or y is equal to 0 or z is equal to 0. That is A1 B2 minus A2 B1 is equal to 0. B1 C2 minus B2 C1 is equal to 0. C1 A2 minus C2 A1 is equal to 0. That implies A1 B2 minus A2 B1 is equal to 0 implies A1 by A2 is equal to B1 by B2. Here B1 by B2 is equal to C1 by C2. Here C1 by C2 is equal to A1 by A2. That implies A1 is to A2 is equal to B1 is to B2 is equal to C1 is to C2. So planes are parallel. Then A1 is to A2 is equal to B1 is to B2 is equal to C1 is to C2. Or given two planes are parallel, that implies their normals are parallel. That implies DRS of normals are proportional. That is A1 is to A2 is equal to B1 is to B2 is equal to C1 is to C2. Next, second one, planes are perpendicular. Perpendicular means theta is equal to 90 degrees. That implies theta is equal to 90, then cos theta is equal to 0. Cos 90 is equal to 0. So A1 A2 plus B1 B2 plus C1 C2 is equal to 0. Or planes are perpendicular implies their normals are perpendicular. That is A1 comma B1 comma C1 into A2 comma B2 comma C2 is equal to 0. That is A1 A2 plus B1 B2 plus C1 C2 is equal to 0. So two planes are perpendicular, then A1 A2 plus B1 B2 plus C1 C2 is equal to 0. Next, here we can observe that A1x plus B1y plus C1z plus D1 is equal to 0. A1x plus B1y plus C1z plus D2 is equal to 0. Here constant D1 is different, remaining constants are same. Then the two planes represent a pair of parallel planes. So two planes are parallel. We can observe the constant D1, D2 are different. Remaining x coefficient, y coefficient, z coefficients are same. That is A1x plus B1y plus C1z plus D1 is equal to 0. A1x plus B1y plus C1z plus D2 is equal to 0 represent a pair of parallel planes. Next, second one, a plane parallel to AX plus BY plus CZ plus D is equal to 0 is AX plus BY plus CZ plus K is equal to 0, where K is an unknown real number. So, any plane parallel to the given plane equation, we can observe constant value are different. That is AX plus BY plus CZ is equal to K. Suppose the given equation, the given plane equation through the point x1 comma y1 comma z1 and parallel to the plane ax plus by plus cz is equal to 0 is ax plus by plus cz is equal to ax1 plus by1 plus cz1. That is the point x1 y1 z1 substituting ax plus by plus cz is equal to k, then the value k represented ax1 plus by1 plus cz1. So the equation of the plane through the point x1 comma y1 comma z1 and parallel to the plane ax plus by plus cz plus d is equal to 0 is ax plus by plus cz is equal to ax1 plus by1 plus cz1. Next, second one, intercept form. So here, if a plane pi intersect the coordinate axis at x-axis a comma 0 comma 0, at y-axis 0 comma b comma 0, at z-axis 0 comma 0 comma c, then a comma b comma c are respectively called the x-intercept, comma the y-intercept, comma the z-intercept of the plane pi. That is, x-intercept is equal to small a, y-intercept is equal to small b, z-intercept is equal to small c. If the plane equation Lx plus My plus Nz is equal to P intersect the axis at A is equal to 0, at A comma 0 comma 0, then x-intercept is equal to A is equal to P by L. Here Lx plus My plus Nz is equal to P, rearrangement, then x by P by L plus y by P by M plus z by P by N. So P by L is the x-intercept and B is equal to P by M is the y-intercept and C is equal to z-intercept is equal to P by N. If a comma ABC not equal to 0 and ax plus by plus cz plus d is equal to 0 is a plane, then its x-intercept is equal to, that is equal to, so ax plus by plus cz is equal to minus d. That implies x by minus d by a plus y by minus d by b plus z by minus d by c is equal to 1. So here x-intercept is equal to a is equal to minus d by a, y-intercept is equal to b is equal to minus d by b, z-intercept c is equal to minus d by c. So in general, equation to the plane making intercepts a comma b comma c on the coordinate axis is x by a plus y by b plus z by c is equal to 1. So we can prove, let pi be the plane making intercept a comma b comma c on the coordinate axis. So x-intercept capital A is equal to a comma 0 comma 0. Y-axis capital B is equal to 0 comma b comma 0. On z-axis capital C is equal to 0 comma 0 comma c. Clearly a comma b comma c are non-collinear points. Let the equation to the plane pi in the normal form be Lx plus My plus Nz is equal to P. Let capital M be the foot of the perpendicular from O to capital origin to plane and L comma M comma N be the DCS of OM. Let OM is equal to P, that is equal to projection of OA on OM, that is equal to AL. Similarly, projection of on second axis, that is equal to P is equal to BM, and third axis P is equal to CN. So from one implies equation to the plane pi is, that is equal to, here P is equal to AL, that implies L is equal to P by A. P is equal to BM, that implies B is equal to P by M. P is equal to Cn, that implies N is equal to P by C. Once again, P is equal to AL implies L is equal to P by A. P is equal to B by M implies M is equal to P by B. P is equal to Cn implies N is equal to P by C. So substituting L, M, N in equation 1, we have x into L is equal to P by A, that is P by A into x plus My. M is equal to P by B, that is equal to P by B into y, plus N is equal to P by C, that is equal to P by C into Z is equal to P. So both sides cancellation P, then x by A plus y by B plus Z by C is equal to 1. That is equation to the plane making intercept A comma B comma C on the coordinate axis is x by A plus y by B plus Z by C is equal to 1. So this is called the intercept of the equation to the plane, and this plane does not passes through the origin. So General equation of the plane equation is ax plus by plus cz plus d is equal to 0, and angle between the two planes is cos theta is equal to a1 a2 plus b1 b2 plus c1 c2 by square root of a1 square plus b1 square plus c1 square into square root of a2 square plus b2 square plus c2 square. And the planes are parallel if and only if a1 is to a2 is equal to b1 is to b2 is equal to c1 is to c2, and the two planes are perpendicular if and only if a1 a2 plus b1 b2 plus c1 c2. Next one, equation to the plane making intercepts a comma b comma c on the coordinate axis is x by a plus y by b plus z by c is equal to 1. So thank you one and all for watching this video. Thank you.